Reactive metal, you said, okay. What about chlorine? What is it? Is it a metal too? It's a non-metal. Very good. So, now, when we talk about, oh, you don't know, that's okay, baby Skittles. So, chlorine is a non-metal. And so here we have a meeting of a metal and a non-metal here in our sodium chloride here that we call table salt. We're going to talk about how they come together. There is a special property of sodium that makes it easy to hang out with. I always want you to imagine in terms of going to a party. When you go to a party, I would like to imagine that atoms hang out that way too. And they choose partners depending on their needs. If somebody has something that I need, you bet I'm going to hang out. If I'm not needed, if somebody doesn't need you, you don't hang out with them. It's the same between sodium and chlorine. Even that chlorine needs that sodium has. There is something that chlorine needs that sodium has. And what is it? What is it that chlorine needs? What does chlorine need? In simple words, what does chlorine need? Why does chlorine want to hang out with sodium? What does chlorine need? What does chlorine want? What does chlorine want? You said cations and anions. Okay. What does chlorine need? You said it needs water. Can you tell me in simple words, what does chlorine need from sodium? It needs electrons. It needs electrons because chlorine is kind of staggering. It's kind of staggering. And in order to be stable, it needs an electron. It needs an electron. And that one electron, sodium has it. And that's why they're going to hang out. Because they need each other in a special way. So, just like people going out, dating, attracted to each other, there is that attraction between the two. And we call that an ionic bond. Sodium can give away its electron, and chlorine is like, oh, this is just right. This is just what I needed. And when I say give away, I want you to be very careful because this is a special meeting. They are hanging out together. So it's a giving away where they have to stay together. It's not like I give you a ball and then I leave. No. Sodium gives the electron and they have to hang out together because there is a very special rule in chemistry that we don't create or destroy things. That electron is not just given away and thrown out. We will talk about that special connection. Hello. And we call this bond an ionic bond. When sodium gives away its electron, what kind of a charge is it giving away? When sodium gives away its electron, what is it giving away exactly? What kind of a charge is an electron? I don't know what I need to use. I'm right here in my kitchen. Yes, it's giving away. Somebody said it's giving away a negative charge. Would you agree with me that then it becomes positive? Does it become positive? Oh, thank you. No, I'm not using 1 to 10? That's not the question I was asked. I have to answer my questions based on what I was asked. So, because it gave away the negative charge, it becomes a little bit more positive than it was before. And what happens to the chlorine as a result? When are you? This is the answer. Oh, you are the person who asked the question. I'm answering your question. I'm answering your question. I'm answering. Oh, no, you're fine. Oh, you're fine. You're fine. No problem, Jeff. That's okay. Zia, you are the owner of the question. Everybody's welcome. You can tell us about the 1 to 10. That's okay. No problem at all. So, when the sodium gives away its electron, what happens to the chlorine? What happens to it? In terms of charge, it has more of a certain charge. Which one would that be? Which one would that be? Which one would it be? Hello, which one would it be? Sodium got rid of its electron. Yes, you're right. It becomes more negative. You guessed right. So now look at what we got. Now we have the sodium ion and the chloride ion. I'm just doing this. I don't have a best way to demonstrate. Now we have ions that are held together by this special thing here that's called the ionic bond. They are charged particles. As one of you said earlier, you can call them anything you want until we get to the board. As long as you have the basic understanding, we will polish it up a little later. And also one thing that's important for us to remember is that it doesn't give it away and back off like that. They still hang together. Zia, okay. You're here. Let me answer your question. You wanted to know about the ionic bonds, and I'm on my small break. I'll start over. The question I asked first was, what kind of a thing is sodium? What would you say sodium is? What is sodium? What is chlorine? What would you say sodium is? What would you say sodium is? It's an element? What kind? What kind? Tell us more. What kind of an element? What kind of an element is sodium? Thank you for liking the live. What kind of an element is sodium? Hello, the heart is here. Let's go. Let's go. Okay. Zia, here is one thing I'm gonna suggest. You were asking me earlier, how do you study geography? We have to listen to the question and answer the question in the sciences and mathematics, maybe in other subjects. It's important for us to listen to the question and answer the question. Hello. Sodium is a metal, yes. And chlorine. What you typed there, Zia? I asked about sodium. What is sodium? I didn't talk about the sodium ions or the chloride ions. Okay. Yes, it's a metal, and chlorine. Hello. Chlorine is also an element. It is a nonmetal. So in sodium chloride, table salts, we have, as you indicated there, a meeting of a sodium ion and a chloride ion. And we just talked about how they come together. And I said, I would like to imagine